Figure 1 shows a sketch of part of the curve with equation y equals e raised to the root of x, where x is greater than 0. The finite region R shown shaded in figure 1 is bounded by the curve, the x-axis, and the lines x equals 4 and x equals 9. Use the trapezium rule with 5 strips of equal width to obtain an estimate for the area of R, giving your answer to 2 decimal places. Now, in order to make 5 strips, we have to know what the width of each strip will be. So we can find that by the upper limit, which is 9, minus the lower limit, which is 4, divided by the number of strips that we want. So we want 5 strips. So it's 5 over 5, which means the length of each strip will be just 1 unit. So we have 4 plus 1 unit, so it'll be 5, and then 5 plus 1, 6, and then we have 7, 8, and then 9. So we have 1, 2, 3, 4, and 5 strips. Now we're going to use the trapezium rule. The formula for this is always given in the exam. And the formula is this: half times the width multiplied by the first height plus 2 times the sum of the middle heights plus the last height. And we also make a table to make it easier for us. So we have all the x values, 4, 5, 6, 7, 8, and 9, and then the corresponding y values. You can find these values using this formula. And then you substitute all these values into the equation for the area. And after doing that, you will get the area as 65.69 units squared. That's the approximate area because we're using the trapezium rule and we're not using integration, so it's just approximate. Now, for part B, use the substitution u equals the root of x. So this is the substitution given to us. We have to use this to find by integrating the exact value of the area of R. So now for the method of substitution, the first thing that we do is differentiate u. So we're given that u is equal to x raised to half. So du over dx will be half x raised to the negative half, which can also be written in this form, which is 1 over 2 root of x. And we need to find dx over du. So dx over du will be the reciprocal of du over dx, which is just 2 root of x. Now we also need to change the limits. Whenever we're using integration by substitution, we have to change the limits. So we have, when x is 4, this is the lower limit, u is the root of 4, which is 2. So the new lower limit now is 2. And the same for when x is 9, so it's 3, u will be 3, so the upper limit is 3. Now, for integration by substitution, we write the exact same formula, but we replace the x. We have to write the exact same formula, but in terms of u. And we also have to change the limits because now we will be integrating with respect to u and not with respect to x. So the limits are here, 2 and 3, and then e raised to u because the root of x is equal to u, so we just replace this by u, and then we write dx over du multiplied by du. So dx over du is 2 root of x multiplied by du. We do this because basically in this equation we had dx, and here we found dx over du equal to root of x, and we can say that dx equals 2 root of x multiplied by du. So basically we're replacing dx by this here. Now I'm going to let I equal this integral, and here one more thing, this root of x is also replaced by u. So we have written the entire thing in terms of u now, and we're integrating it with respect to u. To integrate this term, we need to use integration by parts, and this is a formula to use integration by parts. Now I am not using the variables u and v because we already have u here, and if I'll use u it'll be more confusing. So I'm actually using x and y, but it's the same thing. So let x equal u, so this u, let x equal u, therefore dx over du equals 1. And let dy over dx equal e raised to u, this part. So therefore y will be e raised to u, the integral of this term, which is e raised to u. Now I is equal to 2. Remember we have a 2 here, we've had a 2 here, so we just take it out of the integral to make it simpler. So the 2 is here, and then the formula. I've just repeated the same formula in terms of x and y. And in the next step, we just replace all the x's and y's from here. So whatever we got for x and y, we just replace it here. And then after we solve it further, we get this answer, which is 4e cubed minus 2e squared. Now this is the exact answer for the area, and in the first part we found the area by using the trapezium rule, and in this part we use the integration by substitution and integration by parts to find the exact area of R. Thank you.